We live in an age of carbon fiber, superconductors, and nanotechnology. We believe we are the masters of matter itself. But what if I told you that 2,000 years ago, ancient engineers were using formulas that our best modern laboratories still cannot decode? From concrete that heals itself under the ocean to swords forged with carbon nanotubes in the age of iron. We aren't just discovering new technologies. We are desperately trying to remember what we've already lost. Today, we look at 8 ancient materials that defy modern science. There is something deeply unsettling about holding a piece of the past and realizing it might be more advanced than the present. We are taught a simple story, that history moves forward, that each generation builds on the last, that technology improves step by step until it reaches us. But scattered across the world, hidden in ruins, buried beneath cities, preserved in museums, are materials that refuse to follow that story. Materials that last longer than anything we can produce today. Materials that behave in ways we don't fully understand. Materials that shouldn't exist, given the tools and knowledge we believe ancient civilizations had. And this is where things start to break. Because if ancient engineers truly created substances that modern science struggles to replicate, then our timeline isn't just incomplete. It's wrong. And what makes this even more uncomfortable is that these are not myths. They are physical objects, tested, analyzed, verified, and still not fully explained. Because this isn't about pyramids or monuments anymore. This is about chemistry, about formulas, about processes that were either lost or deliberately hidden. Some researchers believe these materials are the result of centuries of trial and error, techniques refined slowly over generations and then forgotten through collapse, war, or time. Others suggest something more unsettling, that ancient civilizations may have understood natural processes at a level we are only beginning to rediscover, working with materials in ways that don't rely on brute force, but on precision, timing, and environmental conditions we still don't fully control. And this is what makes researchers uncomfortable, because if that's true, then progress isn't a straight line. It's fragile, and it can be lost. But here's where it gets strange. Because the first material on this list doesn't just survive time. It gets stronger because of it. It was poured over 2,000 years ago into the sea itself. And instead of crumbling, instead of dissolving, it did something no modern material should be able to do. It healed. And in doing so, it became nearly indestructible. This is not theory. This is Roman marine concrete. And it's about to change everything you think you know about ancient engineering. It was never supposed to survive. Concrete, by its very nature, is temporary. It cracks. It erodes. Salt water destroys it from the inside out. Modern engineers know this well. Coastal structures today are designed with lifespans measured in decades, maybe a century if we're careful. But along the shores of the Mediterranean, something impossible still stands. Massive Roman harbors, piers, and breakwaters submerged for over 2,000 years. And they're not falling apart. They're getting stronger. This is Roman marine concrete. At first glance, it looks ordinary. A mixture of volcanic ash, lime, and seawater. Simple ingredients. Nothing exotic. Nothing that should outperform modern reinforced concrete. But here's where it gets strange. When scientists analyzed samples of this material, they found something unexpected. Over time, as seawater seeped into the concrete, it triggered a chemical reaction that formed rare minerals, crystals that actually reinforced the structure from within. In other words, the ocean didn't destroy it. It activated it. The official explanation is that Roman builders unknowingly created a perfect chemical recipe by combining volcanic ash with seawater, allowing these reactions to occur naturally over centuries. And that's possible. But this is where things don't quite add up. Because modern attempts to replicate this process have struggled to achieve the same long-term durability. The exact ratios, the timing, even the temperature conditions, something is missing. Some researchers believe the Romans had a deeper practical understanding of material behavior than we assume. Others suggest their methods may have involved techniques or environmental controls we haven't fully reconstructed. Because if this was intentional, it wasn't just construction. It was chemistry engineered to evolve. And that raises an uncomfortable question. What else did they know that we've forgotten? Because the next material doesn't just resist time. It resists nature itself. In the heart of India, standing exposed to the elements for over 1,600 years, there is a massive iron pillar. Rain, heat, humidity, oxidation. Everything that should have destroyed it didn't. This is the Iron Pillar of Delhi. Standing over 7 meters tall, made of nearly pure iron, it should be covered in rust. Modern iron structures begin corroding within years. Within decades, they degrade. Within centuries, they disappear. But this pillar remains, almost untouched. And this is where it gets uncomfortable. Because when scientists examined the surface, they discovered a thin protective layer, a passive film that prevents corrosion from spreading. The official explanation suggests that the high phosphorus content in the iron, combined with environmental conditions, created this natural protective barrier over time. And again, that makes sense. But here's the problem. Modern metallurgy can replicate similar compositions, yet rarely achieves the same level of long-term stability in open environments. Something about the forging process, the temperature, the cooling, or the treatment of the metal remains unclear. Some researchers believe ancient smiths developed precise techniques that controlled impurities in ways we still don't fully understand. Others suggest that traditional methods, lost over time, may hold the key. Because if this wasn't an accident, then this pillar isn't just a monument. It's a formula, and that formula has been standing in plain sight for over 1,000 years. But the next material doesn't just challenge durability. It challenges logic. Because according to ancient accounts, there once existed a glass that could not shatter. Flexible, resilient, almost alive. They called it vitrum flexile. The story comes from ancient Rome. A craftsman presents a glass bowl to the emperor. He drops it on the ground. Instead of shattering, it dents. Like metal. The emperor, stunned, asks if anyone else knows how to make it. The craftsman says no. And according to the story, the emperor orders him executed. To protect the secret. The official explanation is simple. Most historians believe this is a myth. An exaggerated tale, possibly symbolic, meant to illustrate the value of knowledge. And that's reasonable. But here's where it gets strange. Because modern materials science has, in recent years, developed flexible glass, using advanced chemical treatments and manufacturing processes. Which raises a question that refuses to go away. If we can do it now, could someone have done something similar then? Some researchers believe the story may be based on a real, lost experiment. Others think it reflects an early understanding of material properties far ahead of its time. Because if even a fraction of this story is true, then the line between myth and memory is much thinner than we think. Some materials don't just survive history. They disappear and take their secrets with them. Because the next discovery isn't something we can study in a lab today. It's something we can't recreate, because we don't even fully know what it was. They called it Greek fire, a weapon so devastating, so uncontrollable, that entire fleets feared it more than any army. Ancient accounts describe a liquid flame launched from ships, igniting on contact, spreading across the surface of the water itself. It couldn't be extinguished with water. In fact, water seemed to make it burn even more violently. Imagine that. Fire that feeds on the ocean. The Byzantine Empire guarded its formula with absolute secrecy. Only a handful of individuals knew how to produce it. The knowledge was never written down in detail, never shared widely, never allowed to spread. And then it vanished. The official explanation suggests that Greek fire was likely a mixture of petroleum-based substances, possibly combined with quicklime or sulfur, creating a chemical reaction that intensified in contact with water. And that's a reasonable theory. But here's where things don't add up. Because no modern reconstruction has perfectly replicated the behavior described in historical records. The exact ignition method, the consistency, the delivery system, all remain uncertain. Some researchers believe the formula involved precise ratios and preparation methods that were lost when the knowledge holders disappeared. Others suggest something more unsettling, that the Byzantines had mastered a controlled chemical reaction we still don't fully understand. Because if that's true, then Greek fire wasn't just a weapon. It was a technology erased from history. And that raises a deeper question. How many discoveries have we lost? Not because they were impossible, but because they were too powerful? And if that wasn't enough, the next material takes us from fire to steel. Not ordinary steel, but something so advanced that even modern scientists struggled to explain it. Damascus steel. For centuries, these blades were legendary. Warriors spoke of swords that could cut through armor, that could slice a silk cloth in midair, that held an edge unlike anything else. But the true mystery wasn't their sharpness. It was their structure. When researchers examined surviving Damascus blades under powerful microscopes, they found something astonishing. Carbon nanotubes. Structures at the nanoscale, only formally understood by modern science in recent decades. And this is where things become deeply uncomfortable. Because these blades were forged over 1,000 years ago, long before microscopes, long before nanotechnology, long before we even knew such structures could exist. The official explanation suggests that the unique properties of Damascus steel came from specific ores and forging techniques, combined with controlled heating and cooling cycles that accidentally produced these nanostructures. And yes, that is possible. But here's the problem. The original method for creating true Damascus steel has been lost. Modern attempts to recreate it have had limited success, but none have perfectly matched the original composition and performance. Something is missing. Some researchers believe ancient smiths unknowingly manipulated material at the nanoscale through precise control of temperature and impurities. Others suggest that the knowledge may have been more intentional than we assume, passed down through generations before disappearing. Because if this wasn't an accident, then ancient metallurgy wasn't primitive. It was advanced in ways we are only beginning to understand. And then, just when you think it couldn't get more strange, we encounter something that shouldn't exist at all. Not a weapon, not a structure, but an object that changes color, depending on how you look at it, depending on the light, depending on something deeper. The Lycurgus Cup. At first glance, it's just a Roman glass vessel. Beautiful, yes. Intricate, certainly. But place it under one type of light, and it glows green. Shine light through it, and it turns deep red. The effect is so dramatic, so precise, that it looks like modern optical technology. But this object is over 1,600 years old. And this is where things stop making sense. Because analysis has revealed that the glass contains tiny particles of gold and silver, dispersed at a scale so small, it interacts with light in complex ways. Nanoparticles. Engineered in ancient Rome. The official explanation suggests that Roman artisans may have accidentally created this effect while experimenting with metal additives in glassmaking. But this is where researchers hesitate, because the distribution of these particles is not random. It's controlled, consistent, deliberate. Some believe this was a rare accident that happened once and was never replicated. Others suggest something more difficult to accept, that ancient craftsmen may have had practical knowledge of manipulating materials at a microscopic level without ever seeing it. Because if that's true, then what we call modern science may not be as new as we think. And what comes next pushes that idea even further. By now, a pattern is impossible to ignore. Across different civilizations, different continents, different centuries, the same thing keeps appearing. Materials that last longer, behave differently, and in some cases, seem to anticipate discoveries we only made in the last few decades. But the final two examples take this even further, because they don't just challenge our understanding of ancient skill. They challenge our understanding of what was even possible. The next material was never officially recorded in ancient texts. There are no surviving formulas, no preserved samples, only fragments of a story and a strange, modern connection. In the 20th century, a material known as starlight was demonstrated publicly. It could withstand extreme heat, protecting objects from temperatures that would normally destroy them instantly. But the formula was never fully released. After its creator passed away, the exact composition was lost. Now here's where it gets strange. Because some researchers have pointed to ancient coatings and materials used in high-temperature environments, kilns, furnaces, even certain ceremonial objects, that show unexpected resistance to heat damage. Not identical to starlight, but similar in behavior. The official explanation is that these ancient materials were likely mixtures of organic compounds, minerals, and ash, creating natural heat-resistant coatings. And that's reasonable. But this is where things become uncomfortable. Because in some cases, the durability of these materials exceeds what we would expect from such simple ingredients. Which raises a quiet question. Did ancient craftsmen discover thermal protection techniques that we are only now rediscovering? Or are we just seeing patterns where none exist? Because if even part of this connection is real, then the idea of lost formulas isn't just history. It's happening right now. And then we arrive at the final material, the one that forces everything into focus. In medieval Europe, long before industrial steel production, a series of swords appeared that shouldn't have existed. They were marked with a name, Ulfberht. At first, they looked like ordinary Viking blades. But when scientists analyzed them, they found something shocking. The steel used in many of these swords was incredibly pure, with carbon content and structural consistency that resembles modern crucible steel, something that wouldn't be widely developed in Europe for centuries. And this is where things fall apart. Because producing this kind of steel requires extremely high temperatures, precise control, and specialized techniques. Conditions that, according to conventional history, didn't exist in that region at that time. The official explanation suggests that these blades may have been made using imported materials, possibly from the Middle East or Asia, where advanced steelmaking techniques already existed. And that is a strong possibility. But here's where it gets strange. Not all Ulfberht swords are equal. Some are made with inferior metal, imitations of the original, which means the true method, the real formula, was rare, limited, and eventually lost. Some researchers believe these swords represent a brief window where knowledge from different cultures intersected and then disappeared. Others suggest something more unsettling, that certain techniques were known, used, and then forgotten as trade routes collapsed and knowledge chains broke. Because if that's true, then history didn't just move forward. It fractured, and as it fractured, pieces of knowledge were left behind, scattered, incomplete, waiting to be rediscovered. And this is where everything comes together. We have concrete that heals itself, iron that refuses to rust, glass that bends instead of breaking, fire that burns on water, steel with nanostructures, objects that manipulate light at the microscopic level.